Hey guys, this is Mr. Rysz here. So we're going to start P3, so the pre-calculus third section of it, and we're going to be looking at functions and graphs. So I got the notes here for you. This first video, there'll be three of them. We're going to be going over function notation, make sure we know how to represent and evaluate a function. We're going to find the domain and range of a function, and then we'll kind of sketch it, but we'll talk about piecewise functions at the end. So let's talk about what a function is. A function is a relation or a relation between two sets of x and y. And we usually look at those as a set of ordered pairs. And we form those as x comma y, where x is the member of the x group and y is the member of the y group. A function from x to y is a relationship between x and y that has the property that any two ordered pairs with the same x value also have the same y value. So we want to make sure that no x can have multiple y values to be a function. So the variable x is usually called our independent variable. If you think about in science class, your independent variables are usually like time, things like that. And then y is your dependent variable. So dependent things are, like population over time or speed over time, things like that. So let's make sure you guys can, this is the same thing visually here, but let's make sure you guys understand the two different ways. And this will be a bigger deal later on when we start doing some derivatives and getting into it. There's implicit form in a function. Implicit form is where just x and y's are together. Not a single one is by itself. So we just have like x squared plus 2y equals 1. That's implicit. Explicit is when we get one of the variables by itself. So typically you guys learn explicit form, which is like y equals, and then we get the y by itself. So when one of the variables by itself is called explicit form. And then you guys usually then in algebra transition to function notation, where you replace y with f of x, meaning that y is really just a function of x, where it all depends on what x is, and that's what we're going to get a value from. So let's make sure we can do this here. If we want to evaluate a function, we're going to try to do some things. So the first one here, we got a function f of x equals x squared plus 7. We're going to evaluate a, b, and c here. All right, so we're going to start here with an easier one, and I'm going to make sure I get my screen annotations working right now. All right, we'll start a here. If I want to find f of 3a, f of 3a. That means I'm going to go to the equation and replace every x with a 3a. So it's going to be not x squared, but 3a squared plus 7. So when we simplify that, f of 3a would be, well, what's 3a squared? That'd be 9a squared plus 7. And that's all we can do. So there's f of 3a. Piece of cake. All right, next one. What's f of b minus 1? So we're going to replace the x with a b minus 1. All right, so b minus 1, that's one we have to be careful of. We want to make sure that we take our time when we FOIL it out. So I'm going to write it out twice. So b minus 1 times b minus 1 plus 7. All right, so if we FOIL that out, we'd get b squared minus 1b. Then another minus 1b, and then a plus 1. Still got a plus 7. So finally, we would get b squared minus 2b plus 8. Not too bad. I'm just simplifying here. All right, and then next, let's do the tough one. All right, this is actually going to be a really big formula that we will spend a lot of time on, but we could still technically do it now. So, all right, we're going to replace, we're going to find three things, and maybe I'll try to color code this. We're going to find f of x plus delta x. Then what we're going to do here is put a f of x, and then we'll put a divided by delta x on the bottom. So let's start out here with the f of x plus delta x. So that means we're going to take this equation here, replace the x with an x plus delta x. So this is part C. This is going to be x plus delta x squared plus 7. So far, so good. All righty. Then next, what I want to do is to put a minus f of x. So I'm going to put minus f of x is x squared plus 7. So if you look so far at what I did in this blue, this is our x plus delta x squared, or this is our f of x plus delta x. Sorry, I looked at the squared and I got confused. And then we have a minus f of x, and then I need to put a all over delta x. Okay, so what we're gonna do is work on simplifying this and making it better. Okay, so what is this? Well, it's squared, so I'm gonna write it out twice. F plus delta x times x plus delta x plus 7. And then on the other side here, still got a, I can distribute that, so minus x squared minus 7. And we still got a all over delta x. Okay. I'm just going to switch to black here because everything's going to start combining. Okay, if I FOIL this, x times x is x squared. X times delta x is x delta x. Delta x times x is x delta x as well. And delta x times delta x is delta x squared. Delta x can be replaced by any variable. Sometimes you'll see this as just h. So, but here we go. Okay, so there's that part. We got a plus 7 from here. Then we got a minus x squared, and then a minus 7 all over delta x. All right, I'm running out of room, but I'm gonna pull this stuff over here and start simplifying. So let's look what happens. What goes on here? We know that this x squared and that minus x squared are gonna cancel out, and this 7 and that minus 7 will cancel each other out, and we'll be left with, we got 2 of these guys, 2 x delta x's, and a delta x squared all over delta x. Well, this top part here, I could factor out, both of these top equations have a delta x. I could take a delta x out and get a 2x plus a single delta x all over delta x. And I did that because if I divide by a delta x, it cancels out there, and we get left with, finally, a 2x plus delta x. So that's the tough one. That's the tough equation there. So if you guys handle that one, this is going to be a really easy section. But we'll go back and we'll look through some easier ones at the end of this video to help you out with the CYU. Okay, scrolling on here. Domains and range. So domains, simply just the list of all possible x values. The range is the list of all possible y values. I always think the easiest way to figure this out is to use the graphing calculator. So if you want to pull up a graphing calculator and pause the video to look at these, or pull up Desmos as we go over this, this will help you out. But I'll try to explain it without going through some things. So it shouldn't be too bad for the first 3, 4, and 5. I'd still probably use a graphing calculator with. Okay, so we got g of x equals x squared minus 5. I know an x squared is a straight up parabola that looks like this, but since it's minus 5, it's going to be shifted down 5. That's just rules of parent function. So the domain, this graph would go all the way to the left, all the way to the right. There'd be no holes in it. So all real numbers, negative infinity to infinity. It's typically how I write all real numbers. I know other teachers have done like that, all real numbers, that works, or just literally write out the words all real numbers, but there we go. All right, the range. How far low does it go for the y? How far high? Well, the lowest it goes would be down to -5, and that would actually include that point. So we're going to include -5 because that's the lowest the graph goes. So we'll use a hard bracket whenever we include something. We go all the way up towards infinity. Remember, range is the lowest to the highest. So how low does that graph go? Down to -5. How high does it go? Infinity and beyond, Buzz Lightyear. Okay, next one. All right, what would this problem be? Okay, so we got 6 minus x cubed. All right, so I know a cubed function starts out low, curves go high, but it's negative, so it's going to do the opposite. So you're just going to go like this. And since we have this 6, it'd still be shifted up 6. All right, how far left, how far right would this go? Well, even though it's real skinny, this would keep going all the way to the left, all the way to the right. Remember, domain can also be like, is there any times where X wouldn't work? So could I plug an X in where this would make a non-real answer? And no, that isn't. So that is an all real answer here. So from negative infinity to infinity. The range is how low, how high does this go? Well, what's the lowest this graph would go? It'd keep going all the way down to the bottom, right? All the way down to negative infinity, that graph would go. How high would it go? It would go all the way up to infinity. And there'd be no point in the graph where we would have a jump or anything like that. So don't have anything to worry about. Okay, next one. Using my memory here, what would negative square root of x plus 6 look like? So I know a square root is a sideways parabola, but it's negative, so it's an upside down sideways parabola. And it is shifted to the plus 6 makes it go to the left 6. So we would have a graph that looks something like this. Once again, verify this stuff on Desmos or on a graphing calculator. All right, so the domain. How far left can we go? Well, we can go all the way over. It goes all the way to the left at negative 6. And think about here too. Remember, domain is list all, what's the we can put negative 6 in here. We can put negative 5, but we can't put negative 7 because that would make the square root negative and then it would make it not exist. So negative 6, and then how far right could we go? We can go all the way up to infinity, because once we get past, all these numbers stay positive, which means the square root would stay positive. So the domain would be negative 6 to infinity. The range. All right, how far does the range go? Well, the range is how far low, how far high. Well, this graph would just keep going down and down and down. Think if I put like negative 100 in, it gets bigger, negative 1,000,000, or not negative 1,000,000, but like 1,000,000, that number gets, so this goes very, very low. It would get negative answers. It would take a long time, but we'd get all of them, all the negatives. How far high does it go? Well, this graph doesn't get any higher than 0. It just kind of stops at 0. We can get 0 as an answer, so we're going to block it off like that. All righty, tangent of x. This is one where we're going to definitely want to get Desmos out. So let's see how well I can do this. Use my mouse. I don't want things to eliminate here. So there we go. Let me open up a tab here and go to Desmos. Ooh, not fun, but we can make it work. So maybe you remember tangents are the crazy ones. Sine, cosine, easy waves. We're just cruising, bud, on a tangent, on some sine waves. All right. Tangent of x. Doggy. So if we look at tangent of x, domain, well, range is easy because this goes all the way low, all the way high. Each and every one of these go all the way low, all the way high. The question is, what's going on here? Where are the gaps? Where are the jumps? So this one, we got to kind of remember some things about our pi unit chart. So if you remember, tan is sine divided by cosine, or the y divided by the x. So when would our y's be 0? See if I can get a table out here. Well, think about a unit circle. Our y's are at 0 when at pi. So let's actually type that in. 3.1415926. Let's see. Oh, I actually get undefined. No, because that's not exactly pi. Maybe can I use the pi symbol here? I'm learning some things about Desmos. Oh man, I got too many things open up right now. No, wait. Is there a pi? No pi symbol right there. You got to be kidding me. Oh, right here. There's the pi. Pi would be, okay. Well, what about pi divided by 2? Is that when there's the jumps? I always get confused. I got to test it out here. Pi divided by 2. That one is undefined. So we got pi over 2 as a jump, and then we'd have another one at 3 pi over 2. Okay. So there's our jump. So going back to our list here now. Once again, we know the range. Let me pick a color here. Get my pen. This one is a tough one. Is negative infinity to infinity, because the graph went all the way up, all the way down. Now the domain, this one is weird, and this will be something we pretty much won't go over too much, but I always want to keep everything within a unit circle. So I would say x cannot equal pi over 2, and x cannot equal 3 pi over 2. That's where we had jumps on a regular unit circle from 0 to 2 pi. So my class, that's all we're focusing on. Now before, you might have had to say like x cannot equal, let's see, pi over 2 plus k pi. Yeah, that's how you'd have to say, where k could be any number. So 1 pi, which would make it 3 pi over 2, or the next one 2 pi, which would make it 5 pi over 2. Or if I added a negative pi, which would make it negative pi over 2. So don't worry about this answer here for the domain. Just tell me within one single unit circle where would it exist. All right, last one here. This one, we're going to use the graphing calculator. It should be easier. So let's look at it. We got x divided by 4 and x plus 2. You know what, guys? We're gonna try to do this in our head, and then we'll verify it on a graphing calculator, because we are smart people. Remember, domain is the list of all possible x values. So would every x value work, or would there be one that doesn't? Well, there's just one that doesn't, right? That x can never equal 2. So we can just say x cannot equal negative 2. I would assume every single one works as well. You don't have to worry about every x, you know, the proper notation should here just, okay, just tell me x cannot equal 2. Now the range, this is where it gets a little difficult. The range here is we're going to be dividing two numbers. Every time we plug in an x, it's going to be some number on the top and some number on the bottom. So if we think about it, we're always going to have some number on the top, some number on the bottom. Now, we could have 0 on the top, right? If we plug in 4, it's going to be fine, because that's going to be a different number on the bottom. If we have 0 on the bottom, that cancels out the domain. So let's see, if we're always going to have some number on the top, they're always going to be different numbers. If I plug in 5, this is going to be a 1 and a 7. If I plug in 10, okay, that's going to be a 6 and a 12. They're always going to be different numbers. So there's no way we can get the same two numbers on the top and bottom, meaning we're never going to get an answer of 1. So we can say y here can never equal 1. That would have been kind of difficult, like in all honesty here, if you haven't done these problems a million times, to know that this cannot equal 1 without graphing it. And so we'll just verify that answer on Desmos right now. So we'll go back to Desmos here, get rid of this table. We got x minus 4 divided by, ooh, I can't do that. X plus 2, go back it up, x minus 4, or plus 4. I think it was minus 4. All right, I gotta zoom up here. So I know, here, you know what, I'm gonna clear all my drawings. Ooh, I zoomed the wrong way. So if we look at this graph right here at -2, we have our jump where it doesn't, and then this line here, the horizontal asymptote is always at 1. We never cross that. Seems to be some yelling going on outside. Okay, one more thing to cover today. Piecewise functions. All right, piecewise functions aren't too bad. We just have to go ahead and evaluate them. The one thing about piecewise function is we have different functions to plug our values into depending on where they're located in our ranges here. So let's get this started here. Let me start drawing here. So this first one, we got f of -2. So which one does -2 go into? Is it less than or equal to 1, or is it greater than 1? It is less than 1, so we're going to plug it into the top one. That's going to be a -2 squared plus 2. So that's a +4 plus 2 would be 6. So we plugged it into the top. All right, next one, 0 here. Where does 0 go? Is 0 less than 1, or is it greater than 1? 0 is less than 1, so we're going to plug it into the top one. So 0 squared plus 2. That'd be 0 plus 2 would be 2. All right, next one here. What about 1? Is 1 less than or equal to 1, or is it greater than 1? 1 is less than or equal to 1, so we still plug it into the top. All right, so that would be a 1 squared plus 2. 1 squared plus 2 is 3. There we go. Okay, now the next question here. Okay, if we have s squared plus 2, is s squared plus 2 less than or equal to 1 or greater than or equal to 1? This one's a little tricky here, but let's think about it. If we have s being squared, any number squared, what's the lowest it could be? See, like if I plug 1 in, 1 squared is 1. If I plug 0 in, 0 squared is 0. If I plug negative 1 in, okay, it becomes positive 1. If I plug negative 2 in, it becomes positive 4. So even negative numbers become here. Positive, or decimals even become positive. So the lowest this answer could be is 0. 0 plus 2 is always going to be, so the lowest this whole thing could be is 2. Meaning even it's the lowest this could ever be is 2. It means it's still going to match this equation here. It's still going to be greater than 1. So we'll plug it into that one. Negative s squared plus 2 plus 1 means we'd have a negative s squared minus 2 plus 1, or a negative s squared minus 1. Okay, so we'll end this video here. Actually, let's take a look at the CYUs. So just so you guys are prepared, I see some people, and unfortunately we kind of had a baptismal by fire here as it comes to starting the year. But if you guys look at CYU1, you can see a lot of this here is just evaluating the function. So you just plug numbers in, get the right answers. I've kept this simple here. This one here, we're going to plug in f of x and then minus f of 1. Maybe we'll do that problem together and go through. So find domains and range, you just click and answer them. So it should be okay. Evaluating the functions, which one does it go into? Let's do this one together here because I think that's the difficult one. All right, so we're going to find f of x, which it already is. F of x is 3x minus 1, then minus f of 1. What is f of 1? If I plug 1 into here, what do I get? 3 minus 1, okay, that'd be 2. So here's f of x minus, that was the answer for f of 1, all over x minus 1. So if I were to simplify that, let's see, this would become a 3x minus 3 over x minus 1. Some of you might see something here. All right, I could factor out a 3 from the top, and this would become an x minus 1 on the top, and I still have an x minus 1 on the bottom. Wowie, wowie, those cancel out, and so our answer here, 3. So I gave you guys an answer. All right, best of luck with this one, guys. Have a great day, and I will see you next time.